We'll do that tomorrow or later, or we'll just answer questions about it. But we figured this would be more fun because it's a little more interactive anyway. So this is about ways that you can kill MySQL performance. I gave this at PHP Tech last year, but it doesn't really. It's kind of agnostic to PHP and MySQL. It could be any programming language. So raise your hand if you're using MySQL 323. Last year there were like 10% of the people. Okay, 4.0, 4.0, 4.1. 5.0, 5.1, 6.0, drizzle. Okay. All right. Anyone using MySQL with a different database at the same time? Postgres, Oracle, SQL Server. Put your hands down. Anyone? So you're all just MySQL. That's kind of cool. Interesting. All right. Who uses it for mainly like data warehousing or analytics type programs? These guys are just versus sort of OLTP or transactional type applications. Mix. Guy in red. Come on, give me something.
Best data. Okay, yeah, I thought it was like best data. Okay. All right. Cool.
Let's see. Storage engines. How many people know there's more than one storage engine to MySQL? Put your hands down. You can raise your hand. That's cool. All right. Who's using MyISAM?
How do we find out? Same type of flavor?
You don't know which storage engine?
No, I have no idea. I know there's more than one. I have no idea which one I'm using.
Show create table, and it'll tell you which engine, or show table status will list out which engine. Very good. Anyone, pop quiz. You can either get a dolphin or an octopus. What's the internal MySQL system tables? What storage engine are they in?
I know.
I got one of these. I want an octopus.
Well, then you can give it to someone else then. Oh, you want an octopus?
Yeah, I've got a dolphin.
Okay, let's take the dolphin back. Give it to me. Okay, yeah, MyISAM currently is the internal system tables are in MyISAM.
Actually.
So. Actually.
Yeah, in here.
Okay, they are stored on.
You taking notes?
Monty's going to keep correcting me. Okay. Most of the information in the system tables, in fact, all of it, is actually stored in memory. But since the memory storage engine, or the heap table type, as it used to be called, all the data in it disappears on server restart. That wouldn't be very good for storing system information, now would it? No. So it's actually kind of a combination of both. But it's not InnoDB. Some people assume that the internal system tables are InnoDB. And a really nice, fun project is to try and convert the MySQL system tables to InnoDB. It doesn't work very well. Anyway, so going on. How many people are developers versus DBAs? DBAs versus developers? Okay, cool. Answer to every question. We all know this because we're all in IT. Depends. It's especially true with MySQL, especially with the storage engines and the architecture that it has. There's no one single right answer, especially for performance-related stuff. Sometimes the different storage engines are going to be beneficial. You're going to mitigate some of the disadvantages. It just depends on the environment, the type of application you're running, that kind of thing. So. These are 15 tips on what not to do. We'll probably get through about 6 of them, but we'll continue on later and you can always ask questions. Thinking too small. So, it's been a while since I did this. If you need to move some serious data or deal with massive scale, you also need to think about the ecosystem in which MySQL lives. So you can't just think about the database. You got to think about the caching layers around it, the web server, proxies, everything in between. It all works together. There's no real reason to just focus on the database because it lives in an ecosystem with a number of other servers. So don't think too small. Think about the ecosystem in which it lives. So yeah, DNS servers, web servers, application servers, proxies, caches, all that kind of stuff, all plays together. Make sure it's playing nicely with each other. This guy, Ask Hansen, if you've ever seen a talk given by him, if you think I'm talking fast, he's Danish, and he speaks English faster than any man I know. But anyway, he's got a lot of different slides on developer.com about handling the ecosystem, having everything working and playing nicely with each other. So I'd recommend that. Let's see. One of the things we recommend is never relying on a single big box architecture. This is a little bit of a religious thing sometimes, but we tend to say don't put everything in the database server. You know, there are scale out strategies where you can scale the application or the web tier a lot easier than you can the database server. So think about things as far as componentizing your application architecture so you can put things into the middle tier or the application tier and not actually have the database server doing everything for your application. Also, don't think too big. So some of the biggest performance gains you're going to get from tuning the database server are going to come from things like the schema and indexing strategies, the actual SQL code that you use in your application. So some people think, oh, well, I can go in and I can tune one little server variable and I'll get like 50% performance increase. That's almost never the case. A lot of times you just got to go to the application code, take a look at the SQL that you're running, run explains on it, see the query execution plans that your application code is generating, and tweak it. Normally, there are 3 to 5 different ways to write the exact same SQL statement, and they're going to have different performance characteristics in each of the ways. So it really is important to go in and get familiar with your application code. Don't sort of abstract it away so that you don't know what's going on inside your application. All right, so here's like a little graphical overview of the way the MySQL server sort of interacts with the different subsystems. The MySQL server is not sort of really nicely componentized like this. It's actually a lot of different layers and subsystems. But if sort of the layman's perspective, this is kind of how things work. You've got a bunch of clients that are connecting to the MySQL server in this sort of network I/O layer. You've got this thing that the MySQL server has called the query cache. We'll get to that in a second. For client connections, it's going to go through the parser and optimizer, and then we have this pluggable storage engine API, which kind of sets MySQL apart from other database systems. It makes MySQL very flexible, but at the same time, you really need to understand the different benefits and disadvantages of the different storage engines. So it adds complexity, but also gives you the flexibility to do what you want with the data. The query cache. So it's one thing that really does set MySQL apart. It's very, very good for read-intensive applications. You do need to know how to control it for mixed read-write applications. There are ways to do that. You can signal the query cache not to cache a specific query using the SQL no cache keyword. But you really have to understand the read and write patterns of your application and design your schema and your SQL code around that. What the query cache actually stores is the actual result set that gets sent back to the client. And so what happens if I do a select, like select star from projects where project ID equals 13. Well, the first time that SQL statement comes in, it gets parsed, optimized, sent out to the storage engine. Storage engine packages it up in this MySQL result struct, and then right before it sends it back to the client, it's going to store it in the query cache. And if another client requests the exact same select statement, it's not going to go through the parser optimization, storage engine layer. It's not going to do any of that. It's just going to return that result struct directly from the query cache, which for read-intensive applications is a huge performance benefit. But the problem with the query cache is that any modification to any table referenced in the select expression, it invalidates any block in the query cache that referenced that table. So if I'm selecting from projects and I've got a bunch of attributes in the project table, some are very frequently updated and some are fairly static, it can cause a lot of contention because you're going to be updating attributes and immediately invalidating what you throw into the query cache. Let's see. Not using explain is another big way to kill performance of the MySQL application. How many people use explain anytime they do any SQL in the server, any select statement? How many people have never used explain? All right. Explain produces the query execution plan that the optimizer has chosen for a select expression. The way to use it is you just tack on explain, you prepend it before the select expression, and it's going to show you the query execution plan. Anybody know what this /G switch on the end is?
Printed out in row.
Yes, printed out in vertical format instead of a columnar-based thing. Which would you like? Dolphin, much better. I agree. Okay, so yeah, that's just a little hint. If you're in the MySQL client, if you suffix with or you end with /G, then that's going to print it in this vertical output, which is great for slides because it almost never fits in the other format. Anyway, the different parts of the explain output will tell you the number one thing is the access strategy that the optimizer is chosen for this specific set. So here what we're doing is we're joining 3 different tables. We're using the film table, the film category table, and the category table, which we've aliased as F, FC, and C. And in each of the rows in the explain output, you can see which set of information, which table is being accessed. So F would be the film category, and C would be the category. And in the type column of the explain output is the access strategy that the optimizer has chosen in order to go grab the information from that set. So for the category, it's just chosen to do a full table scan, which is the all table type. And then it's doing a reference or a join into the film category table. And then finally, a primary key join using an ecref strategy. Analyzing the access, type output, the access strategy, is one of the first things you want to do when you look at the explain output. If you see all or full table scan and you've put in a where condition, a filter, to winnow down the result set, and you're seeing all come up, that's usually a pretty bad sign. It usually means you don't have an index where a range or an equality condition can filter, or that the condition that you're applying has such a broad number of results returned that it's just going to prefer to do a full table scan or an index scan. If you see index pop up in the type column, it means you're doing a full sequential index scan, which is not necessarily a good thing. If you see using index pop up in the extra column, that means it's a covering index, meaning that the MySQL server did not need to go into the actual data file in order to grab more information for the select query. It could get all the information it needed for that set from an index, and therefore did not need to dive into the data file. So this is a good thing to see using index pop up in the extra column. It's not necessarily a good thing to see index pop up in the type column. Yeah?
Why would you do an index scan?
Well, you might do an index scan if you're sequentially reading all the records in an index. Maybe you want to get the list of all primary keys, or you want to get the list of all keys that are in an index, and you don't supply a where condition. So that would be one. But usually when it pops up, it's because you don't have either a correct index in the right order or something like that. So, all right. One little thing in 5.0 and beyond, there's a neat little optimization called the index merge optimization. There's 3 different types of it. And prior to 5.0, the optimizer could only use one index. So if there were multiple indexes that could possibly be used to satisfy the condition, the optimizer would have to choose one of them. And one nasty little thing prior to MySQL 5.0 that manifested itself quite badly in the optimizer was when you're doing OR conditions. So it would usually default to a full table scan if you do an OR condition prior to MySQL 5.0, even if it had indexes that it could use. In 5.0, it uses this index merge strategy to use both indexes simultaneously in order to satisfy the condition. And this is what kind of pops up in the explain to show you that it's being used. So, like I said here, prior to 5.0, this would pretty much be a full table scan. But in 5.0, you see the index merge access strategy pop up, and I've kind of color-coded it to correspond to the different conditions in the where clause here. And you can see that both keys are actually being used by the optimizer. And unfortunately, I've covered over it here, but you can see using sort union, and then it prints out the 2 indexes that are actually being used. So this is an example of additions that have been made to the optimizer for specific select where conditions that it's handling quite well. All right, choosing the wrong data types. This is something I like to bring up all the time because I see in schemas on the forums and all over the place whenever I go visit people. How many people use big int unsigned for like their primary key identifiers? I know there's at least one in this crowd. No one wants to admit it though. Okay, the basic rule of thumb is the smaller the data types and the smaller you can make your records, the more records will fit into a single block of memory or on disk, and so the faster your seeks and scans are going to be. If you don't need a data type like big ints, right? If you don't plan on having more than 4.27 something billion rows in your table, use an int unsigned, all right, and as an auto increment. There's no reason to have a big int in there. Okay, so just make the data types as small as you can to fit the data that you need. Also, normalize. You want to normalize first and denormalize only when it'll give you a performance benefit. This is if anyone ever go to dailywtf.com, it's a blog of all this stupid IT stuff that we do in the industry. Well, this was a blog post about a year and a half ago called Journey to the Center of the Database. So I always like to put in my slides. And, well, instead of using the actual data type, the data architect of this specific application decided that they would make a table called dates_TB. Anyone can recognize this as a SQL Server Enterprise Manager diagram? Anyway, that would contain every possible date that the application could possibly use, possibly into the future, who knows, and then describe the date in this table, and then instead of using a date data type, relate it back to every table in the application that would need a date column. My favorite, the date column. I've always loved that. See it? Date. Okay. Use the data type that's appropriate for things. Don't over-normalize like in that situation. Normalize, then denormalize, but only in extreme circumstances. Don't go overboard like that guy. All right. Especially important for index fields is the data type that you select. Also make sure both sides of a join. I've seen this a number of times. Sometimes you'll have like a varchar or a char primary key, and you'll have a foreign key that's also indexed to that, and then you'll change the primary key to int or whatever. Maybe you make a schema change, and you forget to change the other side. Well, you basically just prohibited the optimizer from using the index on the child table by doing that. Make sure both sides of a foreign key relationship have the same exact data type. Okay, how many people, how do anyone store IP addresses, IPv4 addresses? What's the data type that you use? Char. Okay, why shouldn't you use char or varchar 15 or 16 or whatever? What is an IPv4 address? What is it internally? It's an unsigned integer. Okay, so the dotted IP notation is just a human readable format of that. And there are two functions in MySQL. One's called inet_a2n, which takes the dotted IP notation and converts it into an unsigned integer, and one's inet_n2a, which converts it back to the dotted IP notation. Always store IPv4 addresses in an int unsigned. Just save yourself the storage space, and it's just a lot easier to work with. And there's those two functions, inet_a2n and n2a. Here's an example of how to do that. So this is what you're using, right? Char 15. Okay. Cut the storage space by 3/4. Store it in an unsigned int. And here's an example of how you can use those two functions to store the exact same information, but yet in a quarter of the space. Anyone using persistent connections in PHP? Don't. There's a number of problems with using persistent connections in PHP. If you use MySQL pconnect, just use MySQL connect. They've resolved some of the problems, but this one still exists. If you zombie a process in Apache, that persistent connection still hangs around, and it means that no other PHP request can use that connection. So I always recommend just use the MySQL_connect, not pconnect function. MySQL connections are remarkably fast compared to other database systems. So there's really no reason to use the persistent connection, especially with PHP, which is a shared nothing architecture. It doesn't maintain state between requests. All right.
Jay, question.
Oh yes, go ahead.
If you're using Java, is it better to open a new connection each time or to use a pool?
Connector J does connection pooling anyway. So this was more for the PHP world, because PHP, you create a request, and at the end it disconnects, garbage collects the request and hands it back to ModPHP.
Fast is for any connection in MySQL. Generally, is it faster to connect to create new ones as opposed to what's the best way that?
I have never seen a situation where the connection time is the bottleneck. Have you? No. It has made sense for other database systems where there's more going on in the connection behavior, but with MySQL, there's really no need. And some of the connectors do it for you because the connectors are more designed for desktop or standalone applications and not web applications. So this is more for PHP specifically.
Actually, there's one case. If you have passwords, then the connection time will be higher. So what you can do instead, just remove passwords, and then you have extremely fast connections.
If you remove passwords, you have extremely fast connections.
Oh, okay.
But in a secure environment, when the speed is essential, that's the way to go.
Right. So Monty's saying in a secure environment where you don't need the passwords, there's no reason to have them. So, and you can speed up the connections. Although I've seen that the connection to MySQL is about 100 times faster than Postgres. So I don't see a whole reason to use persistent connections. So. Okay, using a heavy DB abstraction layer, I'm just going to skip through this. Not understanding storage engines. So, like we showed before, this is sort of an overview of the way MySQL works. How many people use MyISAM again? How many people use InnoDB? How many people use the memory storage engine? Okay, should take advantage of the storage engines for what they offer. Anyone know what's cool about the memory storage engine? Okay, whenever you make a temporary table, either implicitly or explicitly, first of all, it gets created as a memory storage engine, unless you say engine equals MyISAM or something else, right? But what happens to the data in a memory storage engine table when the server's restarted? Bye-bye. That's why it's called memory, yes? So what is it good for then? There's a number of things it's really good for. So the first one is when you want to pin specific information in memory, right? The second one is when you're doing data that's either aggregated or summary type information. So it's data that can be reproduced from your regular tables. So for instance, if you've got some sort of caching table or you don't want to recalculate the score of something, you can put it in a memory storage engine table. The server restarts and goes bye-bye. Okay, you can recalculate that whatever was in that table from your other tables. So those are two important uses for the memory storage engine. Two other things to say about this. Anyone, for a dolphin, or yeah, we got my dolphins. Anyone know the configuration variable that goes in my.cnf or my.ini on Windows that allows you to tell the server to load all the SQL from a specific file before any client connections actually connect to the server? It's very useful for the memory storage engine table because you can load up all your memory storage engine tables with a script before any client connections connect. Anybody? Bueller? Okay, it's called init_file. So you can put this configuration variable in your my.cnf file, init_file, and give it a path to an SQL file that then gets executed before any client connections connect to the database server. And so in that SQL file, you can load up memory storage engine tables, or execute some selects with a group by, aggregate from your regular tables, and store it in the memory storage engine table as a summary of information in the database. So it's a really, really useful configuration variable to know. Init_file. All right, somebody's got to have a dolphin. Come on. Who wants a dolphin? Giuseppe, throw. Okay, so what was the name of that variable again? Very good. Someone's paying attention. All right, so storage engines. I think it's one of the most misunderstood parts of MySQL. People really don't know the disadvantages and the benefits of the different storage engines. And even if they do, some people don't know how to mitigate the disadvantages and take advantage of the benefits in another way. How many people use replication? All right. What's cool about replication is you can have a different storage engine on the slave than you do on the master. So one of the limitations, InnoDB is a great storage engine, right? It's got row-level locking, it does transactions, foreign key constraints, ACID compliant, all that kind of stuff. Great storage engine. But it's got its downsides, one of which is it doesn't support full-text indexing. What storage engine supports full-text indexing? MyISAM, currently. But what if I've got some blobby or text fields that I want to run full-text indexing on? Well, I can replicate off a slave and set my storage engine to MyISAM on the slave and push my full-text queries to that slave. And so its replication is really flexible in that manner. So even if you don't know all the storage engines right now, investigate them, because it's really easy to set up replication and take advantage of the different storage engines while still, if you want referential integrity on the master, just keep things in InnoDB, but you can throw a slave out there and take advantage of full text indexing and set the storage engine for a specific table to MyISIM on the slave. So, archive, yeah.
Will that still apply with the new replication?
Row-based replication?
That's what they're...
So statement-based replication is what we have up until 5.1. And with 5.1, there's row-based replication and statement-based replication, or you can do the hybrid, what are we calling it? Mixed. Okay. Row-based replication, I believe the only engines that support it are InnoDB and Falcon?
Everything works transparent.
Okay. I know Falcon doesn't support statement-based, but...
No, the master forces some queries to do row-based, but you can have any other storage engine on the receiving side of the slave.
What row-based... Yeah? Yes, so Monty was saying that the MySQL server, if it recognizes that a query is in need of row-based replication in order to be consistent from the master to the slave, because there are specific situations with temporary tables and with, gosh, I'm blanking, certain functions that don't return the same value given the same parameters, it will switch into row-based replication and use a mixed mode. Is that basically what you were saying? Okay. Does that make sense? Okay. All right. Anyone ever use the archive storage engine? Yes? Very, very cool. Very, very high insert rates. Great compression rates with zlib. One really, really cool thing that some people don't think is a really cool thing is that the archive storage engine does not support update or delete. Well, Brian says it kind of does, but whatever. It doesn't support update or delete. What makes this ideal for is audit tables. You don't want audit tables to be updated or deleted from. There's a way to delete with some truncatability with partitioning, but we won't go there. All right, so it's ideal for doing auditing work or weblog, that kind of stuff. Especially with partitioning in 5.1, archive does get quite interesting because you can use partition pruning to store log data, say from an Apache web server log, and prune the partition with an event, something like that. So, memory we already went over. I'm going to go through this. Okay, not understanding the query cache. Query cache design. I kind of explained it earlier. It's what stores a MySQL results structure, a set of MySQL results, sends it back to the client if it sees the exact same select expression sent to the server, and no modifications have been done on the underlying tables. The design of the query cache is kind of a trade-off between CPU usage and performance. Doesn't want to spend a whole lot of time trying to figure out which blocks in the query cache have actually been affected by an update or an insert. It just says any modification to any underlying table, it's going to invalidate any block that references that table in the query cache. So you've got to understand the way that the query cache was designed to make sure that if you are selecting from a table that has high update rates or high insert rates, high modification rates, you want to make sure that you use the select. I think I got to this. You use the select space SQL _no _ cache keyword, which indicates to the query cache, don't cache the result of the select, because I know the underlying table has a lot of data modifications to it. This is an important point. Bigger query cache does not necessarily mean better performance. There are ways that you can check the performance and the hit ratios of the query cache. Okay. Using the show status like QC command. I think I got that coming up here. This is the last one I'll do. I'm being kicked off. Okay. So what we're going to do here is battle the query cache thrashing effect that sometimes happens. So here we've got a products table, and we're mixing static and frequently updated attributes in the same table. So let's say we've got some web application that displays product pages. And each time we go to the product page, we want to update the number of views, or we're just doing a simple hit count, something like that. Well, let's say we go to the web page. The first thing we do is select star from products, where products ID equals 13. Goes and grabs this information, gets parsed, optimized, down to the storage engine layer, gets packaged, thrown into the query cache, and then sent back to the client. What's the next thing that happens? Client says, update products set num views equal num views plus 1, where product ID equals 13. What just happened? You just put something in the query cache that you immediately invalidated with the very next statement. And so what happens is the query cache just fills up with stuff that it never uses. So you get basically no hits on the query cache, and you're full. And so it starts doing low memory prunes, and the design of it is a little weird, so it can take some time to do this. And so you're not getting any benefit out of the query cache, because you're mixing very frequently updated attributes with static attributes. The way to battle this kind of thing is to split it into two tables. Split your frequently updated stuff away from your static attributes. That way we go into the product page, the view page, and we say select star from products where product ID equals 13, goes and grabs this information, stores it in the query cache, and then we update this table. Update product counts, set num views equal num views plus 1, where product ID equals 13, and what we just put in the query cache stays in there. So the next time the product page comes up, it doesn't have to do the actual select from the products table, because it's essentially static data. It's not stuff that's going to change a whole lot. So, anyway, I've got loads more tips. I'm welcome for questions and all that kind of stuff, but I think I got to leave for the next person. So, thanks.